Hey Year 12s, another video here. We are looking not at definite integrals today or indefinite integrals. We're going closer to definite integrals. We are looking at areas, this time not a signed area. We are looking at that sort of broad definition of area, right? The sort of space that occupies in two dimensions between a curve and an axis, typically. Okay, that's what we want to look at here. Things to remember when we're doing this is that, first of all, we need to sketch it. We possibly need to factorize it so we can find the roots, because where the function should fall either below or to the left of an axis, right, we produce negative values, and that will produce a negative signed area, but I don't want any negative areas, right? I need to work out the negative parts separately, take the absolute value of those, right, because we want all of our components of that area to be positive. First example here, I think fairly clearly explains what we're doing. So I have a curve here, a function, it's a cubic, right? So it's going to have three intercepts. And what are the intercepts? Well, they are the x-intercepts are what x values make y equal to 0. Right, so that's when x equals 0, x equals -1, and x equals 2. Let's sketch that. Okay, it's a cubic, it has a positive cubed term. So at -1, in fact that's going to be in the road, isn't it? What I should really do is draw my curve first. And then put my intercepts on afterwards. -1 there and 2 there. So those are my intercepts. That's the first part done. Gold. Now shade the region enclosed by the x-axis and the curve. So that's this part here and this part here. Righto. And I need to calculate the area. Well, I'm going to call that area 1 just for the sake of clarity, and that area 2. And let's work these things out. So area 1. Area 1 is the integral from -1 to 0 of, we've got the expansion here, x cubed minus x squared minus 2x dx, which equals 1/4 of x to the 4 minus 1/3 of x cubed minus x squared between -1 and 0. Don't make the mistake of starting at -1 and then subtracting the 0 case. That would be wrong. We've got to go from, we take the furthest right first. Okay, so we put this one out. So that gives me, well, I put 0 through there, I get nothing. I put the -1 through there, I get 0 minus negative 5/12, which equals, of course, 5/12. Right, that's first area. This one here, 5/12. Area 2 equals the integral, this time from 0 to 2 of the same thing, of x cubed minus x squared minus 2x dx. Okay, and that equals from here, I guess I could just reuse that same thing and change the bounds. We can do it, that's fun. 1/4 x to the 4 minus 1/3 x cubed minus x squared, this time between 0 and 2, and what do I get there? Well, if I put, hang on, I'm going to press pause and work this out, save the video time. Okay, and when I work that one out, because, I end up with this negative value, -20/3, right? Now, that makes a fair bit of sense. We come back and have a look here. It is underneath the x-axis, so I should expect to get a negative. Now, I don't want a negative here. What I really need is the absolute value of all of that. So, tell you what, I am just going to say I should put these absolute value bounds around everything, and I'm just going to rub that out, 20/3 is my answer. So my total area is equal to 5/12 plus 20/3. Well, that would be 85/12? 85/12, and I'm pretty sure they don't have any common factors. I guess I could write that as mixed number, but I prefer improper fraction, so, There we go. That's my area total. Now, the last part of that question asked me to run the integral, the definite integral, between -1 and 2. So I'm just going to say here the integral of, look, I'm going to take a shortcut, function x dx, because we've already seen the function back there. From, now we said from -1 to 2. What happens here is this one here, the 1/4 of x to the 4 minus 1/3 of x cubed minus x squared between -1 and 2. What happens when I punch those numbers in? Well, I'm pretty sure what happens is I get -20/3, -20/3 minus 5/12. In fact, instead of adding these two things together, I get the difference of them, and I get 75/3. Well, I end up with a negative number. I end up with something quite different. I get the difference of them, and why? Why do I get a different figure? Why can't I do this all at once? Because some of those figures are treated as negatives. Right? When we're talking about the area, strictly as area, we're talking about the magnitude, the absolute value. It's got to be positive. When I run it all together like this, I can't even say, well, that's a negative answer, I'll just make it positive. No, because I have found the difference of these two areas, right? And I can make that a positive, but that's not the same thing as making both of these positives and combining them together. That's okay. Righto. Well, what's happened with my video? Oh, there we go. That's it. I think that's long enough for the first one. It's going to be a multi-parter again. I'm sorry. Righto. Check that out. Hit us up if you've got any problems.